Good morning, everybody. Mr. Inyard here. Hope you're having a great morning. It's a little dark outside and it's a little early, so it's a little darker on my face. But we have ourselves, let's see, morning work, Wednesday, week 31. Let's do it. All right, so week 31 Wednesday, we're going to continue with some volume questions. And to find volume, we do length times width times height. So we've got 5 times 4 times 3. In all reality, we could do height times width times length. Just remember, our rules of multiplication still apply. So I am going to do 12, 3 times 4 is 12, times 5, since that's just a routine fact. And I'm going to do 60, and then our units are centimeters. And remember, it's centimeters times centimeters times centimeters, which is centimeters to the third power, or what we can call centimeters cubed, because we're literally making 60 little 1 by 1 by 1 cubes inside this box to find its actual volume when we multiply those three things together. 5 times 4 creates a layer of 20 at the bottom, and then you do that 3 times going up. All right, let's look at number 2. I'm going to do 72, right? 72 is 8 times 9 times 10, which is just 720, and that's going to be feet cubed for our volume. Okay, so good review on a box plot here using these numbers. These are all we need to make a good box plot, but we do need to pay attention most importantly to the minimum and the maximum in order to evenly distribute our number line. So for me, I'm not going to start at 5. I like going by 5s to include numbers, and but I'm going to start before 5 so that I have a little space between where I start. And then 17 is the end. Right, that's our maximum, so that's not going to be the very end of my line. My line's going to go just past 17, so I'm going to actually start at 0, and I'm going to go to 20, and now I'm just going to divide this up, so half would be 10, and then half of each of those would be my 5 and my 15, and now I can put in my individuals. 1, 2, 3, 4, 6, 7, 8, 9, 11, 12, 13, 14, 16, 17, 18, 19. And that's pretty close to, as good as I can make it. So now I just put my points in. My minimum is 5, so I'm going to put a little dot above the 5, right? That's supposed to be a dot, but my maximum is 17, so I'm going to put a little dot above 17. That's a better dot. My median is 13. Now median is quartile 2. So 13, I'm going to put a line, right, just like that, for my median, or quartile 2. First quartile is 7, so I'm going to put a line just like that here, and then third quartile is 15. And now I just make a box around my quartiles, and then I draw my connector to my minimum and my maximum. And there we have our appropriate box plot with our appropriate number line. All right, so those who like cooking probably know this. All right, we have pints and cups. The question is, what's our proportion? In order to solve this, we need to know how many pints are in a cup now, or how many cups are in a pint. Sorry. Cups are the smaller unit here. Pints are bigger. Pints aren't quite as big as quarts, right? So you guys remember we have several models we can use. Right, so we have Gallon Man, Mr. Gallon, right here. You maybe have seen this, and maybe you've seen Captain Capacity. This is from a Teachers Pay Teachers person and tutor or something. But then there was also another one. And this is probably the one you see in your classrooms because it's the poster I know I had in mine, even though we made one of these when I was in 3rd and 4th grade teaching, because these are just fun to make. But G for gallon, right? That's our big one. We have 4 quarts inside of that. Then we have 2 pints inside each quart. So there's 8 pints per gallon. And then there's 2 cups inside each pint. And so this is to help remind you that 1 pint equals 2 cups. So remember, cups is my smaller unit. So my number of my smaller unit will be bigger. So I'm actually going to be doing 18 divided by 2, which is going to be 9 pints. And so I can set that up like this. I'll zoom in real quick. I can do 18 cups to X pints, right? And then I'm going to say that that's equal to 1 pint and 2 cups, right? That is my proportion, right? So 18, how did I get to 2? I divided by 9. So what am I going to do to X? I'm going to divide it by 9, which means how do I get the opposite direction? How do I go from 2 to 18? Isn't that times 9? So what do I have to do to my 1 here? Times 9. So no matter what, X equals 9. And there you have our cup of pint proportion. And a good review on percentages. Again, I have videos specifically for finding percentages of amounts, so go look at those on Edpuzzle. But for the sake of this, we know of is multiplication, and so we're literally just going to do 108 times 16% as a decimal, which is 0.16. And so we've got our 48, and then our 4, then our 6. We drop our 0. Remember, we're thinking of this as simply 108 times 16, and then at the end we'll add our 2 decimal place values. 2 and a 1, 7 and a 1. And so again, 2 decimal place values in 0.16 and 16%, none in 108. So I need 2 here, and my answer would be 17 and 28 hundredths is 16% of 108. And so area of irregular figures, we just make them composite with somewhat regular. So I'm going to draw a line here, and I'm going to draw a line here, which means this is 2 and this is 2, which gives us a total of 8 on top, right? Because we have the 4 right here. So this section would be 4, and then we have 2 and 2. So 2, 4, 8. And that should give us everything we need. So the top is an 8. Oh, I need to figure out the split of this right here. This is also 2. Since the total was 4, and this section is 2, its opposite is 2, meaning this is 2. And since we have 6 over here, and this was a total of 4, we are going to say, since all these are right angles, that this has to be 4 as well. All right, so we have a 4 by 2 down low, which is 8 square feet. We have the 8 by 2, which is 16 square feet. And then we have the 2 by 2, which is 4 square feet. And now I just combine those to get 28 feet squared as our total area. And for this one, I'm going to draw a line right here. And so I know this is a 15 by 6, which is going to be, let's see, 75 is 5, so 90 square inches. And then the bottom is 9 by what? Well, it tells you right here. It's a 9 by 5. But we could figure out this is 5 because, again, our total is 15. It says so right there. And we have a 5 here on the right and a 5 on the left, leaving us 5 more to make 15. And a 9 by 5 is 45 inches squared. So we're just going to combine those to be 135 inches squared. And area of a trapezoid is simply, again, we're just going to cut into our triangles and our rectangles, since those are the easy ones we can do. We don't care about the diagonal over here, right? What we care about is the height and the base of our triangles. But we do know that we have a 16 by 13 rectangle. Sorry, not 16, a 6 by 13 inside. So 12 times 6 is 72. So one more 6 would be 78 miles squared inside. So now to figure out the base of the triangle. Okay, now remember, these aren't exactly scale models. If the top is 6, this bottom is 6. Now the total is 18. And we have 2 equal pieces on either side. So if we have 18 minus 6, that leaves us 12 between the 2 sides. So we'll say that base plus base equals 12, and they both have to be the same value. What are they? Right, they're 6. So we have a base of 6 and a height of 13 for each triangle. So we're going to be doing 13 times 6 over 2, right? So we're doing 78 divided by 2 to find the area of one of those triangles. However, we have 2 of them, right? Which means we're going to be multiplying by 2, which is going to cancel those. So it just leaves us to 78. So we just got 78 plus 78, the 2 triangles plus the rectangle inside. So that leaves us 156 miles squared for our total area. And the good news here is we just have one triangle, and we're just going to be doing base times height divided by 2. And so we have 3 as our height, 12 as our base, which is going to give us 36 divided by 2, which is going to be 18 square yards. Boom. Okay, so the distributive property means we are going to distribute or share or give, right, what's outside the parentheses, which is times 4, to each item in the parentheses. So the rule states I can do 4 times 6, which is going to be 24. And then I'm going to bring my addition sign down. And then I can do 4 times 7, which is going to be 28. And if I add those together, I'll get the same answer I would as if I did 6 plus 7, which is 13, times 4. So if I use PEMDAS versus distributive property, they both work, right? And so that's going to give us 52. And 13 times 4 is also going to give us 52. But this represents the distributive property because I'm distributing what's outside the parentheses to each item in the parentheses. As always, if you have any questions, message me on Schoology or comment or like the video, and have a great day.